In this lesson, we're going to be focusing on distances in space. Now you may be asking, why are we talking about astronomers' tools when we're talking about distances in space? Well, the distances between stars in space and us and the sun and stars have been very crucial for technology innovations that helped us understand the world around us as we know it, especially historically. So astronomers made constantly new discoveries and innovations and gained more knowledge about us and our world and what we see based on the distances of stars in space. The first one we're going to look at is a sundial. Sundials are used to tell time and have been around for more than 7,000 years. It is the distance of the light from the sun shining on this little picture here, the sundial, that gives us a certain time. Next, we have the Mercat. Ancient Egyptians used the Mercat to chart and later predict the movement of stars. Now, there's also something called a quadrant that was used by the Egyptians. The quadrant was used to measure a star's height above the horizon. So now we're going to go to Arabia, where we have an astrolabe. An astrolabe was used to make accurate charts of the stars. This again was very important for navigating around the world. If you could have an accurate chart of the stars, they were able to use those positions to help us navigate. Next, we're going to have the cross staff. The cross staff was used to measure the angle between the moon and any given star. Then finally came Galileo, who we learned before, invented the telescope. So now that we have learned about ancient technologies and innovations which used those distant out stars from a distance and their unique positioning to help us understand our position on Earth and certain times of Earth and plot the times and predict things, now we're going to look at what is the distance between these actual stars and planets in our solar system and in the galaxy. So first of all, we have to look at a certain distance, a unit called an astronomical unit. Now, one astronomical unit is essentially 150 million kilometers, or to be exact, it is 149,599,000 kilometers. Okay, so why did we pick one astronomical unit? Well, the reason is this right here is the distance of Earth to the Sun. So when do we use astronomical units? This huge number is only used within our solar system. It is not used outside of our solar system. So here I have a chart that shows the distances of planets in our solar system from the Sun. So right here it says Mercury is 0.39 astronomical units. So if I want to put that in kilometers, I have to multiply this number here by 0.39 astronomical units, and that will give me my kilometers. Now Venus is 0.72 astronomical units from the Sun. Then Earth is 1 astronomical unit. Then we get Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Now the neat thing is, if we actually put this to scale, this is really, really off. And I have a video to show you about that and in class. So now we're going to look at how fast light travels. Well, light travels at 300,000 kilometers per second. Or in other words, that's 3 times 10 to the 8 meters per second. So that's a 3 with 8 zeros. When you hear things are light years away, what does that mean? So let's analyze this for a second. How many seconds are there in a minute? There are 60 seconds in a minute. How many seconds are there in an hour? There are 3,600 seconds in an hour, which is times by 60. How many seconds are there in a day? Well, I have to times 3,600 by 24, because there's 24 hours in a day. That's going to give me 86,400 seconds in a day. Now, how many seconds are there in a year? Well, I have to multiply this 86,400 by 365.25 days, which gives me 31 million. 31 million 500 and 1,600 seconds. So in other words, when we're talking about a light year, that is going to be 9.5 times 10 to the 12 kilometers. So in other words, that is 9, 5, and then we're going to have 11 zeros. Kilometers. So that's how far it travels in a year. So when they say something is a light year, we're talking about this many kilometers. It's actually not a measurement in time, it is a distance. So this is 1 light year. Now Kepler 22b is 600 light years away. What does that mean is I multiply this many kilometers by 600. In other words, we know how fast light can travel. So if we say it's 600 light years away, that means it takes 600 years for the light to reach us. Because light isn't quite instant, even though for us on the small scale things we see, it seems instant. But in reality, light travels at a certain speed. It is 3 times 10 to the 8 meters per second, or 300,000 kilometers per second. So if something is 600 light years away, it takes 600 years for the light to reach us on Earth in a vacuum. So in some ways, it's like looking into the past. So even though I see a planet, this Kepler 22b, it might have been destroyed 200 years ago, but I still see it because the light I see from that planet is 600 years old. Because it takes 600 years for the light to reach here. Because it takes that long to reach that distance. So it can take a long time for light to travel to Earth. So here's an example of something more within our realm. Light from the moon takes approximately only 1 second to reach Earth. Light from the sun takes actually 8 minutes to reach Earth. So every time we look at a sun, I don't advise you to do so, what we see actually happened 8 minutes ago. So anytime we look at the star Kepler 22b, it took 600 years ago is what we're seeing. So that is why a lot of people say that when we are seeing stars, we're actually looking deep into the past.